Hello, we're going to talk about topic 5, section 7, optimization. All right, optimization. That's when we want to basically maximize or minimize something. Um, you're you're finding the optimal moment. Okay, so again, this is the text explanation. Okay, um, I think it's easier to just do it with examples. So let's do a few examples. All right, you have a can of dog food, contains 500 cubic centimeters of food. So we want to maximize our profits. So first you want to remember some formulas. You've got a can, so hopefully you remember that the volume of a cylinder is pi r squared times the height. And hopefully you know that the surface area is essentially two circles, so 2 pi r squared, that's a squared, and that's supposed to be an r. All right, plus the like the label of a can, which is like a rectangle, so that you would take the circumference, 2 pi r times the height is the area of that label. Okay, anyway, so those are our formulas we want to know. Now, we want to find so that it can have the minimum surface area. So I need a formula. Well, I know that 500 is the volume, so the volume must be pi r squared h, so that's a restriction I have, all right, or constraint. Now I use that in my surface area. So again, my surface area is 2 pi r squared plus 2 pi r h. Well, I can get rid of the h because of this formula. I can rewrite that as 500 divided by pi r squared equals h. So let me take that and replace the h right here. So our surface area is now 2 pi r squared plus 2 pi r 500 pi r squared. So we simplify, we get 2 pi r squared, and that becomes 1,000, and the pi's cancel, and we get it r to the negative 1, or over r, either way. So we want to maximize our profits. So let's see. I'm sorry, minimize our surface area. Why do I keep looking at that? Minimize our surface area. So we need to find those dimensions. So what we're going to do is we're going to take the derivative of this. Let me do it a different color. Computer's being a little slow. So if we take the derivative of this, we're going to get 4 pi r minus 1,000 r to the negative 2. And if we set that equal to 0, that's going to find our maximum minimum points. Remember our turning points? So let's see, 1,000 r to the negative 2. I don't like the fraction, so I'm going to multiply everything by r squared. So we get 4 pi r cubed minus 1,000. And then we can plug that into our calculator, right, our poly simulation. But remember, 4 pi is your coefficient. Don't forget the pi. So put 4 times pi as your coefficient in front of the r cubed. So using that solver, you're going to get r equals 4.3. Ooh, that's a weird looking 3. All right, 4.3. And now we need to make sure that it's a minimum. So think about it. How do we check if it's a minimum? Think about your number line. You've already checked 4.3. That's got a slope of 0. So check your numbers around it. Check at 4. Check at 5. What's the derivative? What's the slope? Is it positive or negative? So find the derivative of 4. So let's see, that's over here. So 4 pi, ooh, looks rough here. 4 pi r, so times 4 minus 1,000, not r, 4 to the negative 2. So we plug that in and we solve and we get negative 12.2. We find the derivative at 5. So 4 pi times 5 minus 1,000, 5 to the negative 2. We plug that in and we get 22.8. So that's a negative slope at 4 and a positive slope at 5. So we're going down 0, up. Okay, that's what that's telling us. So it's a minimum. So that's what we wanted. Okay, so we got our minimum surface area. So the best dimension is when the radius is 4.3. So how do we figure out what the other one is, the h? Okay, well, we got to plug it back in. Okay, so plug that into your original equation, and you should get h is, I believe it was 8.6. So your dimensions should be that. Okay, again, this is just tying everything together. I know it's a little weird. Let's do a few more. So find the positive values of x and y so that x plus y equals 60 and x cubed y times y is a maximum. So this is our equation. Okay, but think about it. If we have our, I don't want to use, well, yeah. If we have our equation, wow, really messing up today. We have our equation, it equals x cubed y. Well, I can't take the derivative of that. I've got too many variables. So we use our constraints. X must be positive, y must be positive, and x plus y equals 60. So y must equal 60 minus x. So now our function is x cubed times 60 minus x, which is just 60 x cubed minus x to the 4th. We want to maximize it, maximum. So we find the derivative. What is that? 180 x squared minus 4x cubed. We do our, we need our derivative to equal 0. So we set that equal. Use our Poly Simulation app and solve. Okay, so here you solve and you get x is 0 or 45, but remember, we want a positive value. So if it's positive, it can't be it can't be 0 because 0 is not positive or negative. So that means it's got to be 45. So we've got x is 45. So we plug that in and we get y equals 60 minus 45. So y must equal 15. All right, and we want to make sure we can always double check it by plugging in your derivatives. Okay, let me get my pen color. Okay, so if you think about your equation, or I'm sorry, you're plugging in your x, you know that the derivative at 45 was 0, so check the derivative at 44. Check the derivative at 46. So the derivative at 44 should be a negative number, and the derivative at 46 should be a positive number. So that way we have a negative slope, a 0 slope, and a positive slope. Why did I do that? All sorts of wrong. Okay, let me rephrase that part. This should have been a positive. This should have been a negative number. let me rewrite that. Okay, so, I'm sorry, when you plug in 44, you should get positive 744. If you plug in 46 into your derivative, you should get a negative 8464. So you have a positive slope, a zero slope, and a negative slope. Now that makes sense. That's a maximum. So we know we should be good. And we've got our answer. Okay, let's do a couple more. All right, so let's see. A farmer wants to build an enclosure. Find the minimum length of fencing required for this enclosure. So one side of the enclosure is a wall and does not need fencing. I'm a visual person, so I'm going to think about my wall being right here, and here's my fence. So I have this side, and this side I need to get. Okay, so I know the area is 72, so x times y is 72. And we want to find the minimum length of fencing, so the perimeter for this enclosure would be 2x plus y. Well, we need to replace a variable. So let's replace the y with 72 over x. So now our perimeter is 2x plus 72 over x. We take the derivative of our perimeter and get 2, what is that, minus 72 over x squared. Okay, following your power rule. So we want to maximize that, or minimize that, sorry, find the minimum length of fence. So we want 0 equals 2 minus 72 over x squared. I'd multiply it by x squared. So we get 2x squared equals minus, thinking there, 72. So I can just finish this out. I don't need to get out my calculator. 36. There we go. So x gets us two answers, 6 or negative 6. But think about this. X represents a side length. Really doesn't make sense for a negative to work, okay? Because this needs to be a positive value. All right, so if 6 is our answer for x, well then we can plug it back in and figure out what y is. 72 over 6, so y is 12. Okay, if we want to double check that it is a minimum, we think of our number line. So our number line, we plugged in 6 and got the derivative to be 0. So then we need to check 5 and 7. So find the derivative at 5 and find the derivative at 7. The derivative at 5 should be negative, and the derivative at 7 should be positive. So that way we have a negative slope, 0 slope, positive slope, which is a minimum. So our answer should be correct. And, what was it asking for? Find the minimum length of fencing. It didn't ask for the dimensions. It asked for how much the minimum perimeter. All right, so the perimeter is 2 times 6 plus 12, which gets us 24. Okay. Always read what they want. Okay, one more. 40 apple trees in an orchard. Each apple tree produces 600 apples a year. Ooh, no, don't want to cancel that. Okay. So this is how I would think about it. So you have the production of your orchard. Okay, I don't like to use O. So you have your production on your orchard. You're going to have 40 trees plus however many you decide to add, so plus each additional tree, all right, times the number of apples on a tree. Okay, so that's your orchard. Has 40 trees plus however many you plant times however many apples are on each tree. Okay, the apples on a tree has to be, well, it usually has 600, but for every tree it plants, it loses 10. So minus 10t. Okay, so each apple tree produces 600 apples minus 10 apples for every tree they plant. Okay, so here we're going to plug that in for A. So we get P equals 40 plus T, sorry, I forgot my equal sign, times 600 minus 10T. Okay, so you FOIL that out and you should get 24,000 plus 200T minus 10T squared. Okay, we take the derivative of that and we get 200 minus 20t. We want to find that when that's 0. So, easy enough to solve. Well, at least add a little equation, right? So t is 10. So we're going to plant 10 trees. Okay, that's our plan. So, how many trees should be added to the existing orchard tree? Okay. We can verify it by looking at the derivative of the numbers around it, 9 and 11. So at 10, we know the derivative was 0. So the derivative at 9 is, what is that, positive? The derivative at 11, the derivative at 11 is, what is that? That's going to be, yeah, negative 20, I believe. So that's negative. So we have a positive slope, 0 slope, negative slope. So this is a maximum. And that's what we're trying to do. We're trying to maximize the total production of apples. Okay, so it should be 10 trees. Let's see. The orchard is 25,000 apples in a year and is cheap for planting 10 new trees. Wait, did it ask us for the maximum? Maximize the total production of apples. Okay, so what they did is they just plugged it in to actually get the number. Sorry, I misunderstood. I didn't realize it was asking for the actual production. So you plug in 10 for T. So our production of apples is now 40 plus 10. Why do I keep forgetting that equal sign? 40 plus 10 times 600 minus 10 times 10. So production should be 50 times 500. So the production of apples should be 25,000 apples. Okay, so that's optimization. Hopefully that makes sense. All right, if not, I'm in class.